Well, in this session we present three different studies that investigate the complex relation between the shape of new technologies, annually digitalization, on the labor market outcomes from different point of view, from different data, from different analytical perspective. Each presentation will last 20 minutes, 40 minutes, 18, no, 20 minutes. And please, Dario, the first contribution is Dario co-authored it with Valentina Gualtieri and Roberto Guarasch.
Okay. Thank you very much, Andrea. Okay, let me very rapidly go to the presentation. First of all, I would like to thank my co-authors already mentioned, Valentina Gualtieri and Roberto Quaranta. This is a joint work with them. This work is part of the research activities that we are also bringing on in the unit and is a part of the set of studies on the relationship between degree or relative routinization of occupations and several labor market outcomes, in this case the dynamics of occupation of employment, so delta N basically. The importance of this work, which is of course an ongoing work, there is just a working paper, so your comments are very much more than welcome, is that we for the first time in an econometric environment exploit and in a deep way the variables of the indagine campionaria professioni that we called the Italian ONET, because it replicates the ONET repertoire by means of a massive survey involving 16,000 workers and covering all the 5 digits occupations in Italy, and reporting more than 400 variables on task, skills, work contents, work organization characteristics. And so the informations that are there are suitable to replicate most of the indicators that have been used in the international literature in order to study the relationship between technological change and employment, wages, both in terms of dynamics and in terms of structure. But more than this, and Armanda Cetrullo will show you in the next half of panel, these indicators are very worth in order to dig into some of the things that have been raised during this morning panel about the role of organization, of hierarchies, of how knowledge is distributed or is concentrated within workplaces. So, very rapidly, I don't want to go through many things that have been more and more addressed, stated, and discussed along these 2 days. We know Freya Dorsmore, Acemoglu Restrepo, Luca Marcolini is here, and with other colleagues at the OECD have also worked to measure empirically the impact of technological change, the mediating role that routine and tasks might have in explaining this relationship. And so there is, I would say, mixed evidence. There is not a conclusive result. For sure, there is an evidence of effects of technological change and the role of the characteristics of work, but still we don't have a conclusive evidence, and we do know that territories, institutions, nations, positioning within global value chains matter as well in order to explain the direction and the magnitude of the relation between these variables. And as Mario Pianta mentioned this morning, this time we don't know if it is different, but for sure it's quite radical, at least in terms of market concentration, for example. And so we might think that this deserves additional effort in terms of understanding. Okay, there are problems in terms of problems or different theoretical approaches and perspective that you can adopt in order to analyze the issues at stake. We heard this morning about how and if is appropriate to use general equilibrium model. Some assumptions should be relaxed. There are conceptual problems as the one that Enrique Fernandez Macias raised. There are measurement issues, of course. These are complex phenomena. We can have the best proxies in the world, but still we are proxying things that are intrinsically immaterial, intrinsically uncertain, and so quite difficult to measure in a kind of univocal way. And then the structural and institutional factors that I've already mentioned. So, which contribution we can take away, at least at this moment, but as said, we are continuing to work also on this version of the paper and of the work with Valentina Roberto. For sure, we are excited because it's the first time that we are allowed to use 2 points in time, because there are 2 ways of this survey, and we are going to do the next one in 2019. So we will be able to compare 3 points in time of such a detailed information on tasks and skills and work attitudes at the occupation level with such a level of disaggregation, and I will show you what turns out from the both descriptive inspection and the first attempt of econometric analysis. Then we have plenty of controls, both worker, let's say, occupation level, but stemming from the rilevazione continua sulle forze di lavoro ISTAT, so a massive amount of information on workers and so on occupation concerning work characteristics, type of contract, gender, age of workers, education, and so on and so forth. So we can clear out, at least in part, for some of these elements that are quite important in driving the relations at stake. Then we did a particular operation in terms of data building, and we connect the weighted average of sectoral level data stemming from 4th digit sectoral level data, so to control at least as much as we can for demand side, structural factors, R&D intensity at the sectoral level, in order to clear out this other part of the story. Demand matters, as has been recalled during the morning. And basically this is it, with an addition that is a very recent one, because the Indagine Campionaria Professioni has an initial part, a set of 30 questions more or less. I would like to recall that these are vis-a-vis interviews with 16,000 workers, and so the quality of the information is quite high, and we tested this throughout, at least with respect to the 2012 edition. And so there are this question on, does in the last 3 years occurred an innovation, a technological innovation in your workplace? Does an organizational innovation occur? So we just plugged in these variables as additional controls to see, even interacting, if this reshapes the main relationships. But as Armanda will show, we are more extensively working on these dimensions, trying to operationalize some of the things that Enrique brilliantly illustrated this morning. And so these are not 5 research questions, because it would be too much, but there is one main. So how much the intensity of routine tasks measured as the standard RTI author and others indicator suggests to measure affect the dynamics of employment in 2 periods of time, let's say before and after the crisis, even if years can be organized in a different way. But still, we look at 2005, 2010, and 2011, 2016. And there is a reason why we split in temporal terms the sample, and I will go back to this in a minute. But still, we test these relationships on these 2 subsamples, seeing if at first on the whole sample, and then looking at segments of the labor market. So young workers, well, first manufacturing vis-a-vis services, knowing from the innovation economics literature that technological trajectory in general are highly differentiated among sectors, but of course we still at least look differentiatedly at manufacturing and services. We look at young workers vis-a-vis the rest of the workforce. Author and Dorn published a paper asking if US jobs were getting old or not. So, I mean, there is a reason to look at this segment of the workforce, and then we look at people with college degree vis-a-vis the rest of the workforce. And finally, I show you the model when we plugged in these technological innovation and organizational innovation variable. Here there is just a recall of the RTI that we built relying on the information that we have in the indagine campionaria professioni. And so, as you can see, but I will also show you descriptives looking at subcomponents of this indicator. And so there is the summation of what we can call routine manual and routine cognitive dimensions, so to say, of work. So elements stemming from questions in the questionnaire referring to encodable and repetitive aspects of work connected to manual tasks. The same applies to cognitive tasks. And then we subtract a set of elements that refer to all these dimensions and components of work that are more left to autonomy, discretionality, creativity of workers, use of ideas and knowledge, and facing differentiated environments in the workplace. Okay, this first densities are just to show you for both the subperiods, and now is the moment to explain you why I cut the time horizon. The reason is the break in the occupation classification that occurred in Italy in 2011, and so there is a matter of comparability of our variables between the 2007 and the 2012 wave. This comparability is more possible if we go up the disaggregation level, but still here, this is just a density of what? Of the values of the RTI by 4-digit occupation, weighting this 4-digit occupation with the log of employees in the initial and in the final year, just to show if there is a shift that, of course, is due to movement in employment terms and not in terms of RTI characteristic, because this is fixed and do not varies across time. What we do see in the first side of the sample is that there is a very small but at least visible shift towards the right. So it seems that the occupations, and particularly among low-skilled and medium-skilled, that are more routinary are increasing in terms of number of employees, at least in Italy. Then we have literature that might explain this. But what we do see when we move to the harsh crisis years, so between 2011 and 2016, is that there is a kind of opposite movement, at least among low skilled. So there seems to be a loss of jobs among low-skilled that are also, according to the values of the RTI that we built using the indagine campionaria, more routinary. Of course, these deserve a more deeper investigation, but still, this was just to give an hint of pictures that can be drawn combining employment data and the variables that we have in the campionaria. Here, rapidly, using the first digit of the occupation classification and forcing it a little bit, but still, this is not that bad at this level of disaggregation. We are comparing the 2005 and 2016 figures. This is log employment and the RTI value, but the RTI values in this case varies, because for the 2015 data we used the 2007 information on routinarity of jobs. For the 2016 we used the 2012 information on the relative routinarity of jobs. And what we do see is that, at least looking at the RTI, that there is a bit of heterogeneity. There not seems to be a clear reduction of jobs with high routinarity level. There is a bit among clericals, a little bit among specialized blue collars, while puzzling enough, it seems that among blue collars and service clericals there is an increase that in this case we should do further investigation to disentangle to what extent is due to a change in contents and quality of jobs or a change in the occupational structure. But look at what turns out if we go separately to the manual tasks only. So looking at the components of the RTI that can be referred only to manual tasks, or at least partly only to manual tasks. Here the heterogeneity is stronger, and interestingly there seems to be a reduction in terms of the number of employees, and most probably even in the degree of routinarity when we look at manual tasks only. And clericals is the group where this phenomenon seems to be more stronger. But interestingly, there is a typo, but this is the cognitive only component. So here we are looking at those dimensions that refer prevalently to encodable and repetitive tasks of the cognitive sphere, even if a net division between the two is not a completely good idea. But let's say that here we do see a generalized increase. So these for sure deserve a further investigation, but matches with the idea that most of the increased routinarity related on also on organizational changes is in services and refers to activities that are okay, so I speed up, that are performed in services. Yeah. So okay, these are just some descriptives. Let me go to the results. Here we estimate a very simple pooled OLS. Since what we can do here is building a dummy, since of course our relevant regressor does not vary over time. So we built a dummy and a robustness check for occupations falling in the 4th and 5th quintile of the RTI distribution, and this is our dummy by means of which we compare employment dynamics and the relationship with regressors of the two groups, the highly routinary and the, let's say, less routinary. The robustness check with 5th digit only has been performed, and results are fairly robust to this check. I will show you just some very rough columns of result with only the relevant regressor to show you the heterogeneities that to me are relevant to see and to discuss. First, very simple specification just against the relevant dummy, then the occupation or worker relevant controls, then with the sectoral level controls and the whole set of dummies. So even if here we don't have the opportunity to use fixed effects or GMM estimation due to the very peculiar kind of empirical setup that we have, we can do something about selection, but I'm still reasoning about that. We saturate in a way the model, at least we try to do this with the large number of controls that we have at hand. So what we do see here is that in the whole sample there seems to be a kind of strongly significant penalization, at least in terms of correlation with delta n when we look at the 2011-2016 sample, while a less clear picture and a more weakest result is detected when we look at the 2005-2010. I do not have time to go through the controls result, but what is interesting in terms of controls is that the sign and the magnitude is very much in line with the data that ISTAT has provided concerning the rise of temporary employment, the young workers that had bad performances in the last 4 or 5 years. So the sign of these controls is more or less in line with the evidence, descriptive evidence that has been put around in the last years and particularly during the crisis. We do see here that strongest results are in services rather than in manufacturing, and this is quite in line with results on the US of Autor and others who do find that the strongest evidence is for services. Here, a kind of puzzling, or maybe not that puzzling result concerns young workers, because what we do see is that there is a strong positive correlation between the dynamics of young workers' employment. How many minutes? One? Okay. Of young workers' employment and degree of task routinarity. And, well, if we do think that Italy is not a country for young people, as has been said extensively in the last year, this can be that not only we reach the Greek level of youth unemployment during the crisis, but also that young workers increasingly find jobs in low-tech services and places where there is also, if we look at the quality of job, a high degree of routinarity. Of course, again, further investigation is needed. I'm not saying that this is conclusive. Just 2 final slides. there are interesting evidence concerning the relationship between routinarity intensity at the occupation level and the distribution of responses of answers provided by interviewees in terms of organizational and technological innovation occurred at the workplace. There seems to be, as you can see, an heterogeneity that deserves to be further inspected. But this is just to say that, well, afterwards Armanda will expand more on that. This is just to show you, looking at the third column, that when we plug in both new technologies and the RTI, the significance of the RTI holds, even if it's weakest in statistical terms. And interestingly enough, there is no significance attached to the interaction term of RTI and technological, but this is the same concerning organizational and innovation. Even it can be noticed that both the two has a negative and significant, even if not that strong, relationship with the dynamics of employment. And well, the interaction terms must be commented, just saying that there not seems to be at this stage a strong overlap of role of routine characteristics of job in explaining the dynamics of employment have occurrence in the recent past of an organizational and innovation. Here, the guess is that we have to work more on the appropriate indicators, and this is what with Marica Virgilito and Armanda we are trying to do, and you will see later. Thank you very much.
Thank you, Dario, for your valuable study. The next one is a paper presented by Luca Marcolin. It's about a cross-country analysis that investigates the relationship between returns of cognitive and non-cognitive skills from OECD adult survey of adult studies, the last 2 rounds, and merged with information derived from a new index of digital penetration industries built by OECD. Please.
Thank you. Yes, that's me, Luca Marcolin. Hello, everybody. So this is joint work with other co-authors in my department, and to a certain extent, it sees the contribution of a much larger proportion of the of people in my directorate in a way that I will explain so far. But most of the errors are entirely mine. So we try to answer the following question: how does the digital transformation affect the demand for skills in the market, in the private sector, I would say? And is this different for cognitive and non-cognitive skills? The kind of answer we are giving is a very short-term one, and needs to be said from straight away. So we are looking at the rewards of skills in terms of wage premium in digital industries, digital-intensive industries versus less digital-intensive industries. And we do this as a cross-section. It's true that we exploit 2 years of the survey, but it's because countries were surveyed, different countries were surveyed in different years. So it's unfortunately not yet a panel. So we exploit a worker level data set, that is the PIAC data set. I'm going to go into more details later on. Now, why is this relevant? Of course, I mean, we want to know more and better how the labor markets are changing in the eve of the digital transformation. And in particular, we want to try to understand what kind of skills workers seem to be needing to face the challenges of this technological transformation. I mean, if one wants to broaden the scope of the research agenda, one could also talk about the contribution of human capital to productivity growth. One can, and it doesn't need to be about the quantity of skills, but it could be about the use of skills, as I was mentioning yesterday morning in my small question. No. So what do we contribute to? I think there's some literature that has already assessed the returns to skills in the cognitive versus non-cognitive sphere, but this has hardly been done in a uniform way by sourcing the cognitive and non-cognitive skills from the same sample. and measuring them in a rather uniform way, and certainly not across country. So we can also control for, to a certain extent, for the existence of innate capabilities, what we call the ability, the unobservable ability of workers. But this, I mean, there has been other approaches that rely on more, let's say, natural experiments. We are not as clear-cut as that, and I'm referring here to Aiding et al. For Sweden. We also investigate the returns to bundles of skills and not simple skills. So it seems pretty odd to imagine that a worker is characterized by a single capability and not by a multiplicity of them. We will not get to the multiplicity in such a refined way. We will stop to 2 skills at the same time, but that's as far as we managed to go. And of course, it's all related to the long stream of literature on tasks, on employment as conceived as a bundle of tasks. Now, so what do we find very, very quickly? So both the cognitive and non-cognitive skills are rewarded by the labor markets. This is not dependent on occupation. So the results hold while controlling for a very detailed set of occupations in which workers are employed or not. So the digital intensive industries, and this is probably the most interesting part, digital intensive industries reward a higher return to certain types of skills, in particular the STEM quantitative, that's perhaps straightforward, but also what we call self-organizational skills, so the ability of workers to decide the tasks on their task on the job. What's more, digital intensive industries reward the bundles of skills way more than less digital intensive sectors, and in particular the bundles of STEM with self-organization skills, but also management and communication skills. Now, in terms of what kind of data we require to run this analysis, it's 2 broad blocks. We need information on skills and we need information on technology. Now, the information on skills is sourced from this individual level, worker level data set that Andrea was mentioning. It's called PIAC, so that stands for the Program for the International Assessment of Adult Skills. Perhaps most of you in the room already know the data set. Anyway, this is a survey of adults that is carried out by the OECD on a cross-country basis and with a uniform questionnaire. It has it covers 22 countries for 2012 and 9 countries for 2015. For each country, approximately 2,000 to 5,000 workers are covered, and there's a load of information about these individuals. While we restrict our samples to employed people, so I'm referring to workers very often, the data set also has information on unemployed people, which we discard for this analysis. Interestingly, the data set contains a specific module where workers are tested for their cognitive skills, and in particular literacy and numeracy skills. If you've ever taken a GRE test or an SAT test, that's the same company that is implementing it. They're designing the questionnaire and implementing it. Of course, the questions are easier, but also through the remaining part of the questionnaire, one can assess the tasks that workers are performing on the job. Now, what do we do with this? Well, we have these three cognitive skills that are assessed through tests, so literacy, numeracy, and problem solving in technology-rich environment, so the latter we will exclude because it's not been tested for Italy, Spain, and France, so that drops our sample size in a significant way. But we also construct these 6 task-based skill indicators, so let's call them task frequencies, which are based on the type of tasks that workers perform on their job. How do we do this? We group the questions of the questionnaire in a way that so a bundle of these questions rotates around a single dimension, and so that the 6 skills, the skills frequencies that we separately measure are substantially orthogonal to each other. This is done through Bayesian-like factor analysis. The references in the paper of Mike Otto's, Robert Grunker, and others in 2017. Now, the second building block is a measure of technology. Well, the data set itself, the PIAC data set doesn't allow for a lot of traction in that respect. So what we do is we source information from external sources. So we try to measure the digital intensity of sectors in this particular case. How do we do this? We start from the baseline idea that the digital transformation is a complex phenomenon that has a multiplicity of dimensions. So we try to populate this multiplicity of dimensions through indicators that can be collected at a uniform level across country and sectors. So we sub-selected these seven actually indicators. ICT investment intensity, so that's ICT of tangible and intangible nature. The intangible nature is, of course, software. We take robot intensity from the International Federation of Robotics. I think Georgios has used the same data for his analysis that we presented yesterday. We also source information from international input-output tables. That's also an OECD product from where we source information on whether sectors are purchasing ICT components or ICT services, so not investment, but intermediate consumption. Finally, we further source information from the microdata survey that the Eurostat is running on ICT adoption in firms, and in particular we focus on e-sales intensity. And lastly, we take the proportion of employment in sectors, which is represented by ICT specialists, and we follow an occupational classification there that has also been put together by the OECD and Eurostat together. Now, we have this for 36 ISIC 4 sectors in a balanced way for a time series ranging from 2001 to 2015, balanced for 12 countries only. Now, why 12 countries? Simply because you require a balanced data set in order to be able to create a taxonomy, which is the outcome of this work. Data coverage is not so easy to come by in a uniform way. Now, methodology and data steps that have been undertaken to construct these indicators, to build together these indicators, are presented in a paper that I myself co-authored with Flavio Calvino and other co-authors that is an STI working paper. Now, this is the outcome. I need to make a long story short, but this is the outcome of that data collection work that we are going to use in this paper. What you see is a list of 2 and 1 digit sectors classified between low digital intensity sector, medium low, medium high, and high digital intensity sectors. Now, you can reproduce this very same table for each indicator, each of the indicators I just presented. Here, the rankings emerging from each of these sub-indicators have been put together in an ad hoc fashion so that we create a single taxonomy. A taxonomy of sectors that then where sectors are then split in these 4 quartiles of digital intensity. Nothing extremely surprising about it, I think. So ICT, services are more digital intensive than non-services sectors. These are the dark blue bars. Some sectors are pretty consistently ranked at the bottom of the digital intensity ranking, namely agriculture, mining, real estate. Now, this is of course only an indicator at the sector level. Within sector heterogeneity is completely missed from this taxonomy. And as a consequence, I have to tell you, it's written in the paper several times, this cannot be considered a perfect measure of the digital economy, and it's built mainly as an instrument, as an analytical instrument to be used in further exercises. Now, does the split between digital intensive and less digital intensive sector tell us anything about the question we want to approach here? Well, from very preliminary descriptive evidence, you see that here, if you take the average skills of workers that are employed in digital intensive versus less digital intensive industries, you see that for each and every skill, there seems to be on average a difference between the skills of these workers, differently employed workers. By the way, the differences do not seem statistically significant, but they are. Now, in a bit more structural way, what do? We run sort of Mincer equations, so where at the worker level, where of course we assume the labor supply is fixed, and so are the product demand elasticities. So if this were true, we could retrieve the price of skills or returns to skills. So some skills are extract a higher return if they are in higher relative demand. Now, once again, we consider the fact that workers do not only display one single skill, but bundles of those, and we split our sample between digital and less digitally intensive industries. Like in more formal terms, this is the estimate in the very reduced form estimating equation, where the log of hourly wages with bonuses in purchasing power parities is regressed on our measures of skills, the interaction of our measures of skills with the digitally intensive dummy, considering whether the worker is employed in a digitally intensive sector versus not, and then a host of individual control variables, age, genders. We experiment with a lot of them. Perhaps in a very interesting way, we control both for a detailed sector dummies and detailed occupational dummies. This is run as a weighted OLS, where the weights are the sampling weights that each individual in PIAC is assigned, so that the results are supposed to be representative at the country level. Now, in whatever follows, the skill variables are going to be standardized, so the magnitudes of coefficients are comparable across skill variables, while the object of interest, of main interest, is actually this interaction here that I'm showing to you. So this is the way we decided to present our regression tables. Hopefully I'm going to do a decent job in explaining it. So the blue bars are the coefficients on the skill variables when the digitally intensive dummy is set to 0. Okay, so this is the elasticity, I would say. Well, it actually represents the percentage change in wages that a worker receives when skills are increased by a standard deviation. Okay, but each of these skills is each of these skills is increased by one standard deviation. All the controls that I just mentioned are included in the regression. I'm just showing the skill coefficients. Now, what you see in the blue bars is that most skills receive a reward in less digital intensive industries. What you also see, though, that is as soon as you move to more digital intensive industries, only two skills receive a significantly higher return, and these are the self-organizational skills and the STEM quantitative skills. So whether for the STEM quantitative skills the intuition is pretty straightforward, perhaps for the self-organizational skills this is less straightforward. What our results imply is that if a worker is employed in a more digital intensive industries, this worker is likely to be asked to be more flexible, more changing the task they do on the job and the place in their organization more frequently than in less digital intensive industries, simply because technologies move faster, and hence the premium on those workers that can show that they can adapt more easily. Now, if we focus instead for a second on digital intensive industries only, so we forget about the less digital intensive industries, but we try to assess the importance of these bundles of skills. We have bundles of many skills, but here I'm focusing on the bundle of other skills together with the STEM quantitative skills, okay? So this is once again the result of our regression analysis. The dark blue bars tells you that given average level of STEM skills, if a worker displays in addition ICT skills, numeracy skills in management, etc., there is a certain reward. But then again, if only for management and communication and self-organization, there is an increase in return if STEM quantitative skills increase above the average. Okay, so what I'm saying is, so for these two skills, the higher your STEM quantitative skills, the higher the return to management and communication skills and to self-organizational skills. Now, what does it mean? It can mean that so jointly these these skills are jointly rewarded better, or simply that STEM quantitative skills become more productive, and hence they receive a higher reward in the moment in which they are coupled by management and communication and self-organizational skills. Now, I can show the same results for numeracy skills and to a certain extent for ICT skills as well. This is in the paper. Now, we do all sorts of robustness checks. I will not go through all of them. Perhaps so here they are. So more interesting, perhaps, is that we try to get into a more robust identification strategy. In particular, we are aware that endogeneity affects our results. The endogeneity, of course, of sectoral dummies. So better paying sectors can attract better minds, and so they can innovate more, and at the same time, pay better their workers. We don't think this is a major concern. Essentially, we tested by lagging the digital taxonomy, using values of the digital taxonomy that are at the beginning of the 2000s and not the contemporaneous to our estimation period. We also point out to the fact that innovation takes a lag in making its own effects, so it's improbable that the higher wages are able to attract better skills, and this is in turn immediately translated into higher innovation. Now, the most concerning part is endogeneity at the individual level. So the workers. So there are most likely unobservable characteristics of workers that determine at the same time their sector of affiliation, their occupation of affiliation, and their wages and their skills, right? So in particular, firm-specific wage could be a culprit. There is reverse causality. Of course, there's a matter of selection. Now, we are treating selection as we speak with modestly successful results. It remains that to account for endogeneity of 8 times 2 variables jointly, because that's what our estimation currently do. So they test they actually have 16 coefficients for the skills. All 16 of them would need to be instrumented, and this is not at all an easy problem to solve. So we just basically revert to estimating a return for each skill separately, but this is also suffering of a certain bias because one skill may capture the correlation of other skills as well, which would be omitted from the specification. Anyway, so that's where we are going, as these conclusions are very preliminary, but if you believe in our context, we are stating that both cognitive and non-cognitive skills do find a reward in the labor market. The digital intensive industries in particular reward self-organization and STEM skills in particular, which points, and of course, the complementarity of human capital and technology, but in a not so straightforward way, meaning mediated by the role of tasks. And then the digital intensive industries also reward the bundles of skills, in particular of STEM quantitative with other skills, more than less digital intensive industries. As a general policy conclusion, but we can open the discussion later on, one should say perhaps arguing that what matters for digitalization is the ability of workers to display STEM skills, or sometimes called ICT skills, or sometimes called digital skills, is probably not enough.
Thank you. Ulrich Ziran is going to show us how the... Giulio? Sorry. The next contribution is by Giulio Verani.
Thank you, Andrea, and thank you, INAPP, for having given ISTAT this chance to give a presentation in this very interesting conference. Well, I'm going to present a very small exercise we carried out at ISTAT, which is less ambitious in analytical terms than the exercise just presented, and more or less in line with the mission of the Statistical Office, which is not just to carry out data analysis, but but also that of performing a constant quality assessment of our data and, if possible, to develop new indicators. The issue was just to test the relationship between capital and skills on the basis of the data currently available and for the period 2011-2015. We started basically with two research questions, but we will not necessarily will have an answer for them. The point is just to try to understand what could be relevant to learn from our data in order also to develop new research activities in this field or to make available our data for further research. Well, the exercise was very much a data-driven exercise because we started with the ISTAT register of employees in enterprises. It means a register of something like 18 million employees for every year, and with a lot of data of these individuals. Out of this big register, we have selected the employees of another very large sample, I would say very large panel, which is the CompNet database. This is an international network activity under the coordination of the European Central Bank. So basically we have around 400,000 enterprises included in the CompNet database with a lot of information and a lot of economic indicators. The point is usually in the official statistics we don't use so much capital indicators for industrial statistics. So we need to use another source, in this case the CompNet database, in order to be able to match some indicators about capital stock and investment at enterprise level with information on employment. And finally, as I will discuss in a few minutes, we have used the microdata on the level degree of digital intensity of Italian enterprises. We have developed this year for several purposes, and we have already used it in several research projects. Of course, we have to adapt. The main problem is that our variables were not predefined. So we have to adapt the variables available in the register or in the CompNet panel to our needs. It means that we have to calculate the investments just to compare the stocks of capital. And we have, for instance, to give our definition of skills, which is quite a basic one, considering three main indicators, as I will show you. We took into consideration the occupational status, basically blue collars, white collars, and managers, and the level of education and the tenure, the work tenure in terms of years. It means how long an employee was working for the same enterprise. I think it's quite important to trying to understand how relevant is the level of formal education in this case to identify a skill. because of course it's may even be more correct just to ask, as the OECD is doing, about the specific skills. But if you have only administrative data to rely on, of course you have to understand to what extent you can use formal education as a good indicator for skills. In this perspective, we have identified 27 groups of skills for each enterprise, for our 400,000 enterprises. As you can see at aggregated level for 2015, we have some big groups, mostly blue collars, and most of them with a medium-low level of education. At the end, the very last groups, of course, are those of managers who, on average, have a higher level of education. And there is a high differentiation in terms of work tenure. But our aim was just to consider at the same time the level of the different indicators composing these indicators with the aggregated indicators of skill, but also to take into consideration the composition of the skill, the skill structure at the enterprise level, which is something we have been able only partially to achieve. Here we are just comparing the structure of the population in terms of skills in 2011 and 2015. There are 2 points to be highlighted here. Overall, we have an increase in the number of employees. We are not considering all Italian enterprises. We are considering more or less 1/10 of Italian enterprises, 400,000 and something on more than 4 million enterprises. But in principle, this should be the best Italian companies in the sense that we are only limited companies, and the average size is pretty high compared to the average size of Italian enterprises. And we can observe that from 2011 to 2015, in this panel, or this sample, if you want, of enterprises, we have a small increase in the total employment, but we have 2 big skill groups reducing their size. And the 2 skill groups at the bottom of the bars are those considering blue collars and white collars with a very low level of education. So basically, we went through 4 main steps. The first was the matching of these 2 big data sets, not without several methodological issues. The second step was to produce some descriptive statistics, and the third step was some exploratory analysis. So, of course, we ran several regressions trying to check for the relationship between different variables. But the result have been really discouraging in the sense that there is a high correlation between more or less all the variables. There is a lot of noise. There are a lot of medium, small enterprises which are not really changing anything in 4 or 5 years, in a 4 or 5 years period. So there is a huge inertia in this panel. And so basically we found quite a weak association between investments and skills, but not really relevant to be further explored. So we changed our approach, and we used this taxonomy of enterprises. We developed it earlier this year by using the microdata from the Italian ICT survey. So the idea here is as such. We have a big problem with the definition of investment and the relation of investment to technology. Because even in the CompNet database, we also have tangible investment and intangible investment. But we do not have idea, for instance, how much investment of machinery or equipment we can find in the tangible investments. So the issue was trying to identify those enterprises which could have been expected to invest more in technology. And we have information because we had micro-funded, basically, information. So we can identify those enterprises which, with, of course, a probabilistic approach, which at the end of the period can be considered more or less digitalized. That's the issue. And we have some results in terms of key indicators. So, first point, in our sample, for more or less all the groups of enterprises, even less for fully digitalized enterprises, the employment is increasing. But at the same time, we have to take into account that also for this sample of enterprises, we have a decreasing productivity, or even on the stagnant one in the case of the fully digitalized enterprises. In terms of capital indicators, I mean capital stock and capital per employee, we can see that basically these enterprises have invested in capital in the period under observation, but at the same time, the increase in the employment has had as a result a reduction in the ratio capital per employee. So basically, the one of the main indicators, at least in our assumption, could measure the investment in new machinery, new technology, is not confirmed here, because it seems that the ratio of capital per employee is decreasing rather than increasing. And this is the investment ratio. As you can see, even the fully digitalized enterprises are reducing the investment over time in the period under consideration, but you have to consider also that the fully digitalized enterprises, of course, they already have a very large stocks of capital. And here we have our indicators about human capital, and basically education and tenure in terms of years. Unfortunately, the result we have from this slide is about the education, is that there is a significant relationship between digitalization and increase of educated employees, or highly educated employees. So there is a quite clear relationship. Unfortunately, the information about tenure is not so useful, and we assume that this is one of the case mentioned also this morning, where the institutional context matters, because probably the stricter rules for retirement introduced in Italy at the beginning of this period have strongly influenced the average tenure in enterprises, so preventing more employees to retire in the period. I can just to sum up some points emerged in the analysis. As I said, we don't have some very stronger results, but we have some points which could help us to improve our base of data, and to develop new and different analysis. I think, well, I have to report that we have performed again some regressions by considering the different the taxonomy of the enterprises in terms of digitalization. And when running the same regressions by considering the taxonomy by digitalization, we still have the relationship between investment and capital and with skills not significant for all classes, but the class of fully digitalized enterprises. In the case of fully digitalized enterprises, we have a strong association, or also a very significant one. So it means that, okay, some indicators of digitalization could be relevant together with more detailed information on the capital stock in order to identify the relationship between capital and skills. But we have to take into account, first of all, that there is this huge inertia in the population of Italian enterprises. Then, according to the evidence we have so far, there is not a clear effect of substitution of labor with capital. It seems even that between 2011 and 2015, enterprises have had the preference for hiring more people rather than investing in new technology. And of course, skill measurement is still an issue. We started by considering 3 variables, but what we are going in the near future is to add the new variables, including salaries, including more specific information on the occupation, mostly because we are in the constant process of collecting more administrative data, and this could help in the future to improve this kind of analysis. Thank you.
Thank you very much, Giulio. Now, Ulrich Zierman turned his attention on what happens in Europe, specifically on the relationship between task-based technological change and aggregate labor demand and employment. Interestingly enough, they found that the negative direct impact of task-based technological change on the employment could be outweighed by creation of new jobs correlated to product demand. Please.
Yeah, thank you very much. Thank you very much for having me. It's a pleasure to be here. So I'm presenting a paper I've been working on for quite a while now, jointly with Terry Gergi, who just changed to IVA, and Anna Salomons from Utrecht University. So, and well, as the title suggests, this is about whether digitization creates more jobs than it destroys. Well, I guess we've heard a bit in the past year, in the past presentations already. There's a huge public debate on a huge public fear that digitization or computerization destroys lots of jobs. So this is from a German newspaper, Der Spiegel. But I guess you found that in many other outlets as well, in many other countries, many other languages. And the figure below the headline, 47% of jobs are at risk. I guess you all know where that comes from, even though I think it's exaggerated because we had some other studies showing that once you take into account that workers adjust, figures are much lower. Anyhow, you find these headlines quite a lot. But actually, if you go back in time, and this is why I chose the German newspaper, they had more or less the same title page, I think, how much does it ago? 40 years ago. So it's not that new. We have been discussing this quite a lot in the past. And actually, if you look inside those documents, you can read the old magazines from the Der Spiegel Online. Now they say that about half of jobs are at risk. Back then they said 80% of jobs not are at risk, but will be lost. So if you look at Germany now, this doesn't seem to be the case. Anyhow, there we have this huge and massive fear in the public debate on jobs being lost, while in the economics debate, at least for quite a long time, there was no fear at all. It was quite the opposite. And this is what Acemoglu and Restrepo call a false dichotomy in their new papers. The reason in economics why we didn't think of technological change as destroying large numbers of jobs is because mostly we have thought of technological change in terms of the skill-biased technological change framework. And there, labor is mostly augmenting the skilled workers, and therefore we have increase in inequality, but no massive unemployment for the low-skilled, except for some extreme parameters, constellations. So, and this is what Acemoglu and Restrepo call the false dichotomy, and therefore the literature recently has changed somewhat. So we have now learned that technological change is not skill biased, but it's actually routine replacing. There are specific tasks that can be done by machines, by computers in particular, and these are the routine tasks that can be replaced. This is what we have discussed yesterday and today, so I don't have to talk very long about this. So these routine tasks can be done by machines, therefore they are being replaced by machines, therefore the routine workers are losing out, and the routine workers are those in the middle of the wage distribution. Then this is why we have polarization, the hollowing out of the middle, and the growing shares of the both high and low skilled workers. This is called polarization, actually stemming from the sociological debate, and economists are discussing this only since I think the Orted alias paper 2003. But most of the discussion in economics so far has been about this polarization, so namely structural change, routine jobs being on the share of routine jobs being on the decline. But what the public debate is mostly about is about the number of jobs, not so much about what the share of routine jobs, but more how many jobs will we have in the future. And there are now some theoretical models which are able to discuss this, which are able to study what are the preconditions for technology to destroy jobs in aggregate, in the number of jobs. For example, the Acemoglu-Restrepo paper, but also quite some others which recently have been appeared. But so far, whether labor races with or against the machine ultimately still is an empirical question. We have theories which can tell us under which condition it can destroy jobs, but still we do not know whether this is the case or not. And this is precisely what our paper is about. So we want to study the question, what is the net employment effect of routine replacing technological change in Europe? So what we do is threefold. First of all, we develop a theoretical framework based on the Großmanning-Salomon's AER paper, where we have three key mechanisms. So first of all, we have this direct substitution of labor by capital. So we do allow routine capital to directly replace the workers. This is different from the skill-wise technological change framework. Secondly, we have compensating effects, so which is on the one hand side the product demand effect. So as firms invest in routine technologies, routine capital, they become more productive and can sell more and can grow and thus create more labor demand. And secondly, as our production opportunities increase due to technological change, our production frontier increases, we become richer, we have higher incomes and can spend that also on other sectors which do not invest into technology, and therefore they will also create new jobs there. So for example, in the local restaurant or hairdresser industry or so on. So we develop a framework which can capture these, on the one hand side, these direct replacement mechanisms, allowing us to estimate how much substitution is going on. But on the other hand, we also include those compensating mechanisms, and then we want to empirically implement that in order to study what has been larger, the substitution or the compensating effects. So we estimate that framework for the European Union as a whole at the regional level for the time period 1999 to 2010. To get at the net effect of technological change, but then we also estimate the contribution of the separate channels in order to see how the effect comes about. And by that we contribute in two ways to the existing literature. First of all, we are the first to study the net employment effect of routine replacing technological change. This is complementing work of others who focused on more narrow, more specific technologies such as robots. So quite a number of papers on robots has appeared in the past. We are complementing that in looking at computerization more broadly. And also we are complementing another work which appeared by Anna Salomons and David Autor recently on TFP increases more broadly. So what they study is what productivity increases mean for the labor market, but they do not study where they come from, these productivity increases. They just take the productivity increases they've given, whereas we study where they might come from, namely from computerization. So this is first contribution. Second contribution is we quantify the mechanisms, and I believe that this is very important because so far we have partly conflicting evidence from the, for example, from the robotics papers. Some of them point to negative estimates for the US, other points to positive effects for Germany, and we do not really know where they come from. One potential reason could be that the size of mechanisms that lie behind that are quite different. And by quantifying the mechanisms, we can understand in more detail how the net effect comes about, and also I believe that when you know the size of the mechanism, this might have some important policy implications, and you will see that later on when I present my results. And also we can use our estimates to make a bridge between theory and empirics, because so far we know the net estimates, we do not really know how they come about, whereas the theory tells us what are the underlying channels, and we then can quantify those channels. So to give you a preview of the results, first of all, we find a net positive employment effect of routine replacement technological change in Europe between 1999 and 2010, and the effect is not that large, but it's positive, contrary to the public fears. Secondly, we do find very strong and significant substitution effects. So it's the positive net effect does not mean that there's no substitution going on. Quite the contrary, we do have strong substitution, and it's only the compensating mechanisms which lead to the overall net positive effect. And I believe that this is a very important finding, in particular because in the public debate we only focus on the substitution potentials and not focus on how many jobs are being created. And therefore I believe it's important to show that substitution effects can be overcompensated by compensating effects, and at least that has been the case also in the recent past in Europe. And then finally, quite an interesting finding, we find that the size of the overall effect depends on where the gains from technological change accrue. So in a nutshell, we don't really know where capital income accrues. So we have two extreme scenarios. The one is the upper bound estimate, where we assume all capital income to accrue within Europe. Then we get the positive effect, the upper bound estimate, or we make the lower bound estimates, where we assume that all the gains from capital income accrue outside Europe, and then we get to the lower bound, which still is positive, but of course smaller. And by the difference between the two, you see that where the gains from capital income accrue plays a role for the overall employment effect, and thus it also relates to some recent theoretical papers. Okay, so I do not have too much time, so I will give you just a brief overview of how the model works. It's quite a large model, but so we do a regional modeling approach. We have regions. In each region, you have two sectors, a tradable sector and a non-tradable sector, and we allow for spillovers between the sectors via demand, via income, so via product demand, via consumption. And we use this regional approach firstly to take into account local spillovers to the local sector, and secondly in order to exploit the regional variation in routine task intensity as a measure for how much the regional sectors are exposed to technological change, to computerization. We then model routine replacing technological change as declining costs for routine capital. We assume it to play out only in the tradable sector. This is basically data-driven because we see it in the tradable sector to occur, but we see very little investments into ICT capital in the local non-tradable, mostly service sectors. However, the local non-tradable sector then is still indirectly affected by that change via the demand spillovers from the tradable sector. So if you earn your income in the tradable sector locally, you spend some of that on the local restaurants or on bars and so on. We then also indirectly capture trade within Europe via trade between the regions in Europe, and this is actually most of the trade that is occurring in Europe. So by that we capture 70% of trade, but we do not take into account trade outside Europe. And now in the new version of the paper, which is now available at CES-IFO, we also take into account labor supply responses. This was not part of the earlier version of the paper that some of you might know. Okay, so here's how it works. We have production, so a firm combines different sets of tasks. So the pointer is this one, okay. So you see, no, this is not. So which button is for the, in the middle, perfect. Okay, so if a firm produces output, then it combines different tasks, task 1, task 2, task 3, and each task itself is produced by combining labor and capital, which both is specific to that task. So think of example of task 1 as a routine task. What we now assume is that the price of capital, routine capital, is on the decline, so that firms will replace the routine workers with routine capital. So this is first substitution going on. And the second substitution is that the firms will, of course, shift towards routine tasks in production because they're becoming cheaper. And therefore, you have these two substitution effects going on. Firms replacing routine workers by routine capital because it's cheaper, and firms using more of the routine tasks, which are increasingly capital intense. So this is the first two effects actually that we estimate. Then secondly, we go to the demand side. So you have all the consumer, they consume the goods bundles from the different regions, and well, they consume both tradables and non-tradables, and the tradables they consume from all the regions. And now assume you are a routine intense region. This means that you can adopt a lot of routine capital, you become a lot cheaper, and thus you can increase your production quite, you can lower your prices quite a lot compared to the other regions. You gain a lot in demand, you attract a lot of demand, you grow, and you adopt more, and you can gain a lot of new demand and grow in terms of employment. So this is a product demand effect, and then the final effect is the local spillover effect. So if you grow a lot in your local tradable sector, you gain a lot of additional income that you then can also spend on the local non-tradable sector, and this will generate new additional jobs in the local non-tradable sector. Okay, this is then we control for labor supply responses. This is in a very stylized fashion following the Ashimoku-Restrepo robotics papers. We just assume that there is a certain elasticity of labor supply. That's all. This allows us to take into account the wage responses. Yeah. Okay, so I have to speed up a bit. So what we then in the end do is we estimate two equations. We estimate the product demand equation. So we estimate a labor demand equation. So labor in region I, occupation J in the tradable sector depends on output of how much the industry produces. It depends on the marginal cost of the industry. It depends on the routine intensity interacted with the time trend, though this represents changes in capital prices over time. And of course, it depends on wages. This is, and the second equation we estimate is the product demand equation, where the output of that tradable sector in the region I depends on the prices of that industry or the marginal cost of that industry, and it also depends on the market potential, that is the size of the market that the region potentially can address. And by estimating these two equations, we can back out key parameters that we need for our that we then later are going to plug into our decomposition. So from the theoretical model, we can derive a decomposition which tells us that the overall effect on employment depends on three additive terms, and these three additive terms are just the effects that I explained to you before. So the first one is the substitution effect, that is labor capital replacing labor. The second one is the product demand effect, that is new product demand creating new jobs. And the last one is the spillover effect. And by estimating those parameters and plugging them into our decomposition, we can directly compute the three effects as well as the overall net effect. So what we do is we estimate those effects. And how much time do I still have? 3 minutes. So, yeah, I'm just going through. Okay, 4 minutes, perfect, great. So I'm just going through the main estimates. So the first one is what we call the routinization effect. So this is the coefficient on the routine task intensity, actually. And you see it's minus 1.7, which means that if your routine intensity is higher by 1 standard deviation, then your employment growth is lower by 1.7 percentage point, which is very close to other estimates from the literature. The second one is the substitution elasticity between the tasks. This tells us how easy it is for firms to switch from one task to another, which is, of course, very important for the substitution effect. And this is about 0.3, which is also close to the Grossman-Salomons estimates. And And from our estimates, we can then back out some other parameters. For example, we can back out the labor share, which is about 2/3, which is very close to what we actually know from the descriptive. So this suggests that the estimates are actually quite reasonable, because there's no restriction on this parameter anywhere in our model. And maybe another interesting one is this one, the gamma R. This is the annual log routine replacing capital price change, implying that the price of routine capital is declining by 7 to 8 percentage points per year, and this is also quite close to other results from the literature who focused on the cost of producing computers, for example. Okay, so when we plug all that into our decomposition, we can get to the following picture, which is just the decomposition. So it's a substitution effect, product demand effect, spillover effect, and the net effect. So we have two bars. The red bars is the net employment effect, where the blue bars are the labor demand effect. That is, assuming wages to be constant and just looking at how firms change their labor demand, assuming that wages were constant. This is what we had in the earlier paper. The red one is what we now do in the new paper, where we control for labor supply responses. And then you see that indeed we do have strong negative substitution effects, close to 2 million jobs lost due to computers replacing workers. However, we have strong compensating effects, so that on net the total effect is positive, with about 1.8 million jobs being created in Europe over the whole time period. This is about 8% of the overall increase in employment over the whole time period. So actually, computerization didn't play that much of a role for overall employment growth, but still the effect was positive. Now, as I mentioned earlier, this is an upper bound estimate, because we do not know where the gains from capital income accrue. So we have just assumed that all the gains from capital income accrue within Europe. Now we do the opposite exercise. We assume that everything accrues outside. And then, of course, the effects become somewhat smaller. It's 1.5 million jobs being created, but still it's positive. So to wrap up, what are the key results? We do find positive net employment effects of routine replacing technological change in Europe. We find that there are very strong negative substitution effects. However, they are overcompensated by the compensating effects. And we do find that the size of the spillover effects depends on where the gains from capital income accrue. So what does it mean? It means, first and foremost, labor has been racing with the machine, not against the machine, but with the machine. And also we find that the labor demand effects are throughoutly larger than the pure employment effects. What does it mean? Well, this means that more jobs would have been created had labor supply been more elastic. So if we manage to help workers switching from declining to growing occupations, this could also help us in getting even more positive employment results. Secondly, and very importantly, focusing on substitution potentials alone is clearly insufficient. Indeed, there's strong substitution going on, but the compensating effects are even larger, and therefore it is very important to take these into account and not being afraid of only all those theoretical technological potentials. And finally, the allocation of the gains that we have from technological change also matters for the employment outcomes. So who owns the capital is an important question. And by that, I finish. Thank you for your attention. If you want to read the paper, you can download it as a SES-IFO working paper now.
Thank you, Rich. Before starting the discussion, it would be interesting to know if your results also excluding Eastern European countries. But anyway, Michele, 10 minutes.
Okay. Thanks, Andrea. Thanks for the INAPP guys for having invited me to this very interesting session. Of course, I will not make technical discussion about 4 papers, otherwise I would have taken 1 hour of time. I will make some general statements that is related to my main research aims that are related to income inequality and intergenerational income inequality, and then to the role of different concept of skills for explaining our idea of inequality. Starting from the standard conventional wisdom that we had since the 80s, that inequality is increasing only because of education, because skills, and then from that point of view, there is a sort of exogenous forces that cannot be contrasted by the policies, and more importantly, according to this view, education is something that is good in terms of process for explaining inequality, and then is a sort of reassuring mechanism behind inequality, the trend of increasing inequality. And from a policy point of view, the only suggestion is to increase education. Now we are completely, fortunately, we are completely in a different environment where we are discussing a lot of different sources of heterogeneity within the concept of human capital, within the concept of skill. And all papers deal with this issue in a very good way from two different perspectives. Some papers, especially those by the OECD colleagues, focus more on price effects, on effects in terms of rewarding. The other papers focus more in terms of composition. What could be the effects in terms of unemployment risk or in terms of total employability according to the different type of concept of skills, of concept of what effectively firms are asking for and are rewarding. Starting from this, and this is also crucial to understand what type of policy intervention could we have and how acceptable are the differences that we can observe within the labor market. Starting from this general review, I can make some specific statement related that came in mind reading your papers and listening to your presentation. First of all, about the paper by Dario, Valentina, and Roberto, I found one crucial issue that refers to having clear in mind that the concept that you are considering are multidimensional. It is very interesting that you find different results when you interact with other characteristics, and then there is a further black box. Is not only explained by the routinary task of job, but depends on the type of age, by the type of education, by the type of sector. And then my suggestion is always to try to go deep into this type of black box, of the new black box. The previous black box was what explained the within inequality, within educational inequality for among people with the same education. Now is what can explain all the type of different bundles that you find in your paper. Even if you look at the occupational outcomes, this is the same type of element. And from another point of view, I find very interesting your approach, because your approach and the idea of using the survey questionnaire made by ISTAT and INAPP, if I'm not wrong, is that by using that type of ONET-based questionnaire, you can try to measure a lot of dimensions of task of jobs that you usually not considered. I discussed with your colleague Roberto about the potentialities of this type of analysis to define exactly how much heavy, how much hazardous, but how much heavy, how much is the type of job that you perform, and also to analyze whether the employment structure is moving towards other different dimensions of individual well-being, of workers' well-being, that are usually overlooked. And that's from that point of view, my guess, my suggestion, of course, it is the same by you, I'm sure, is to try to move the analysis from an occupational-based analysis to an individual-based analysis once, for instance, mandatory communications or other type of data are available and allow you to follow individuals over time to analyze whether there is a replaceability. Individuals are replaced by individuals with different type of tasks, of skills, or the same individuals is trained by firms to become less routinary and more cognitive based. And this type of approach should be invested more. About the paper by Giulio, I have one remark that is based on some previous analysis that maybe can complement your analysis. You focus on occupation, on the structure of occupation. In some analysis made by using INPS data, INPS administrative data, and then focusing on earnings, I found that, at least for the case of Italy, because Italy is the only country that I where I can follow the same individuals over time for many years, I found that all the dimensions that you consider, then education in the third level, occupation, sector of activity, tenure, and so on, explain a very limited share of wage inequality, but more importantly, a decreasing share of wage inequality among time from the starting of the 90s up to the most recent years. And then we have some effects in terms of composition, but when we look at price effects, these determinants have a very low explanatory power. What does it depend on? Maybe on some very strong residual at the firm level that we cannot control, and then again it is maybe related to what Dario said, it is related to what effectively we are asking to individuals that is not captured by occupation and education, and then this is also important. About the paper by Ulrich and his colleagues, I found very interesting, I found crucial that you focused on and general equilibrium approach. Because, for instance, even if I'm carrying out a similar paper about the Sinus syndrome for Italy, I criticize the approach that otherwise seems that you are focusing on a general effect. If I found that, for instance, China effect reduces prospects of working in manufacturing, it doesn't mean that the general total effect is negative. And I liked a lot your approach from that point of view. I have one main question, one main concern. If I understand well, you focus on employment without distinguishing what type of employment you are referring to. If there is a positive net effect, is that effect related to an increasing share of atypical contracts? Is it related to an increasing heterogeneity, increasing inequality within workers? Because, of course, employment is a crucial dimension to assess a phenomenon, but we should assess the same phenomenon also looking at other objectives. The economic policy should have to focus on employment levels, but have also to focus on other effects that are related to this employment level. Skill bias, if it worked, it could have increased occupation for you according to the conventional wisdom, but have also increased a lot earnings inequality. Then what is the possible effect on inequality? Of course, you have no wages, but in terms of the internal composition, what do you guess could be effect? Is the net increase in employment rate offset by possible increase in heterogeneities or no? And then this is one aspect. Few words, final words about the paper by Luca and colleagues. I found it very interesting because it is, from many years, I'm trying to understand what determines the rewards, then the black box of within wage inequality within all that we observe. And from that point of view, I found it crucial to take into account competencies, looking at PIAC data, to take into account soft skills, even if one caveat I would suggest you, because you observe not the endowment of soft skills, but the use of soft skills that is completely different also from an economic policy point of view of how we can invest to reduce this type of inequality. Anyway, I have some, my question for the discussion is about the policy implication, because it is clear that if you have that type of approach that you found that firms reward education by individual educational degree, the standard type of interpretation of the social investment state is to increase educational level. But when we notice that differences are based on some measures that maybe are related to quality of education, and then the policy suggestion is completely different, because you should invest in homogeneous education. And then, for instance, from the university level, you have to contrast, to clash against the idea of creating elite university rather than other university. Otherwise, you are further differentiating the endowments of individuals. And especially if we notice that firms are rewarding maybe much more, or anyway are rewarding soft skill, a part of the caveat that I already stressed, how soft skills are accumulated. This type of further skill more easily accumulated by those who come from a better background and then also create problems in terms of intergenerational inequality. How can we create educational policies that increase the two types of skills that you find that are relevant? And then this is the reason why maybe we are trying to move towards a less reassuring interpretation of inequality related to skills, but also we have to analyze exactly how this type of skills are accumulated, how this type of skills are obtained. One final remark is about the case of Italy, because I used PIAC data from that type of looking for the black box idea, and I made some regression on Italy, analyzing the residual inequality, some indicators of residual inequality, controlling for all that you can control in PIAC, the type of education, the field of study, and so on. What we found, I did not include proxies of soft skills because of the reason that I stressed before. But once I add, at the end of the process, literacy and numeracy as a driver, as a determinant, as a correlate of earnings of Italian workers, I do not find anything. From that point of view, what is the issue? They are significant, the star emerges. But in terms of our capacity to understand the total inequality, the effect is very limited. It only explains. Then my final suggestion is that associated with these very interesting results at finding whether these characteristics are rewarded, also how much they are able to explain, how large remain residual once you control for that. Thanks a lot for the attention.
If you want, you have 3 minutes to respond about the issue.
We can collect 3, no more than 3.
No more than 3.
No, I mean we can collect maybe 3 questions and then we respond.
Yeah, so we have time. It's not enough. But anyway, please, Ulrich.
Yeah, I'll try to make it short. So, unfortunately, the number of questions we can answer within the single paper is limited. So we it was tough enough to answer that one. But yeah, there's something we can say about wages and inequality. I mean, clearly there's polarization going on behind that. We didn't really discuss it in detail. Now we have the labor supply responses in there, so now we can discuss wages. But we decided to skip that into a second paper. So please wait a bit.
That was only one question. I mean, that's unfair. Thank you very much for the many comments. I think the use versus endowment of skills is absolutely well spotted. Part of this is wording, and I tend to be a poor presenter, but part of it underlies an assumption whereby we assume that if you're allowed to be doing your task frequently on the job, it's because you're good at what you do. Otherwise, your employer would move you away from the spot in which you are. So there's an equivalence between frequency and say productivity or quality of what you do. But I mean, it can be discussed. So. On the last question, I've never really looked into sort of inequality as an outcome variable, I have to say, oddly enough. I cannot really sort of come up with a good explanation. I think so. I would argue, try not to put literacy and numeracy together in the same box. For instance, they usually drive each other down. But I'm the first to admit that although my coefficients are sizable enough, I think when you look at other correlates of wages, there are first order correlates that are more important than the skills we do. Like incredibly gender. It's perhaps like not such a surprise, but I mean whether the worker is female or male, it makes a way larger, like in the order of 10% to 10 times a larger impact than this thing, than our variable. Now on the policy side. I wouldn't go as far as to argue that we do not need more education. I think so this is a blanket recommendation that I think we should all always keep in our mind. But then, of course, quantity and quality need to be distinguished, right? I mean, for reasons that really, I went to a public school, and I'm very happy in Pordenone, and I'm very happy of the quality that I received. But for some reason, it doesn't seem to be the case for a large part of the country. We rank consistently low in international rankings for the literacy and numeracy that are displayed by individuals when they are tested. Of course, this is all about it's different than their received quality. I need to cut it short. Yes. So I would say. Policy prescriptions, what kind of training is needed later on. It's not only about basic education, it's about continuous adult learning and how the skills are actually put into place in the company, so organizational skills.
Okay, I will spend 30 seconds. Thank you very much, Michele, for reading and commenting on the paper, and I completely agree. I mean, among the step forwards, there are for sure additional interactions and, for example, contracts which are a proxy, if you want, of the heterogeneous institutional characteristics of labor markets attached to different occupations is something that we would like to explore. Besides, for example, the presence of migrants, the relative share of migrants into specific labor markets, because again, this can be a relevant proxy of the characteristics of labor supply that might affect the dynamics of employment, but not only. And then, thank you.
A very short comment, because you raised a very important issue, and well, which is in principle is I understood that your point was just to follow the individual, which is not just an employee; it's an individual, and with different, with of course life cycles, well, the tasks and objectives and so on, and it makes sense to use all the available data to shed some light on how the individuals are behaving with the reference with these different variables. I have to stress a point that as a result of some division of labor in the Statistical Institute, our aim was not so much focusing on individuals, but rather focusing on firm strategy. So really, at the firms were at the center of our analysis for two main reasons, with two main objectives. The first one was to provide some additional and possibly improved methods for analysis. Last but not least, new methods of classification of firms. For instance, I would like to raise the issue whether the Pareto taxonomy, extensively used in economic analysis, is still useful when considering this kind of technology and not the technologies which were more common 20 or 30 years ago. Another point is about the policy. It's about which kind of result we can have in terms of policy, and it's not a case that we are planning to extend our analysis by considering the effects of the industrial policy implemented by the previous Italian government, just to giving incentives to enterprises to invest more in technology. Whether these these policies have been effective, and if which effects they have had on employment.
Okay, thank you. Thank you. Before closing this session, the last question by Professor Vivarelli.
A comment to Ulrich's presentation, a good presentation, but I'm really puzzled. You claim to investigate the relationship between technology and employment, but you don't have technology neither in your model nor in your data and your specification. You don't have patents, you don't have R&D, you don't have robots. What you have is declining cost of capital in routine versus non-routine task, that at best is an indirect measure of the kind of induced technological change due to prices effects. That explains something of the technological change, but a few parts. And then you have the routine task index that is at best an index of vulnerability of some sectors towards the new technologies. But here you come in a circular kind of and tautological kind of framework, because again, not having any on the right side that is really representing technologies, you tend to confuse the impact and the effect. And so I think that it could be a useful descriptive exercise, but cannot claim that is something connected with technological shocks and technological change, because you don't have them.
Thank you.
Yeah, thanks for your comment. Well, clearly we only have an indirect indicator of technological change. That's very unfortunate, but it's the one that is very established in the literature. It has already been shown that it's very closely correlated to to direct measures of technological change, in particular computerization. So therefore, we are very confident that it directly measures what we claim it does. I mean, this is what has already been shown by others. If we had a direct indicator, we would of course use this, and this is actually something we're currently doing. We collected a survey among German firms where we have direct measures, not only of computerization but also of technological change at the current frontier. We linked it to the social security records, and now we're studying this directly. So and also in this data, we already see that these routine indicators are very good indicators to capture what technological change or what computerization is.
Thank you. We meet here again in 10 minutes. Coffee break, please.
No, well, for the good of us and of the last speakers and for the respect that we need to them, please, 12 minutes sharp, we will start again.